All right. Now, let's look at this first problem. Because what's going to happen here is that somebody's going to try to cancel. Why can't I? Because it's not a multiplication problem, right? So, I want you to look at that numerator and think about something that we did yesterday. Can you see anything special about that numerator? Zoe? No, it won't be on the sheet. The numerator will not be on the sheet. No, they can't take anything out.
Oh,
The difference of squares.
It's the difference of squares. The numerator is the difference of squares. And how does that factor? Come on.
cosine of x
Cosine.
minus 2.
Minus 2 and
Cosine of x.
cosine plus 2. Beautiful. Now, as soon as I factored, it becomes cosine minus 2 times cosine plus 2.
So you can cancel.
So now I can cancel, and the answer is just cosine x plus 2, which is that. Okay, so what do we have to recognize? We have to recognize that the numerator is the difference of squares. Now, what about this one? Now, Tilly, now you can look at your pink sheet. This is actually on the pink sheet. Now, it might look a little different. Remember we talked about how these identities over here, and if you haven't already drawn a circle around it, there's a circle around those. We're going to use those a lot. The Pythagorean identities. What can you tell me about 1 minus sine squared? Well, don't we have one that says sine squared plus cosine squared equals 1?
Yeah.
So if we were to move this to the other side, wouldn't it say cosine squared equals 1 minus sine squared? Remember, all these things on your pink sheet, you can move those around. Move them around. So 1 minus sine squared is equal to what? Cosine squared. So I can change this into cosine squared. Now, what about secant? What's secant? 1 over cosine? Whoa, guys, what's going to happen? I have 1 over cosine squared times cosine squared over 1.
You can go, it's like you want.
There, it's just 1. Everything's gone. It's just 1. Remember, your job is to simplify. So you're looking for ways to cancel things out, to simplify your problem. Okay, 14. Remember, I've used thetas in this problem. Change them to x's if you want. The letter you use doesn't matter. The variable you use doesn't matter, okay? Any thoughts on this one? Now, do you see how nothing's squared? So we're not looking at our Pythagorean identities because in those identities everything's squared, right? Okay, so we're not looking there. What are we thinking about? When we see a cosecant, what pops into your head? 1 over sine. And what about tangent? Sine over cosine. And then we have a plus 1 over cosine, secant. Now, be careful in this problem. You see how these two are being multiplied? So that means those two you can cancel if you wish. Well, I think that would be a good idea, don't you? So in between my hands just equals 1 over cosine, right? And then plus another 1 over cosine. Well, wait a minute, what's 1 over cosine? Secant. So I have a secant plus another secant. So 1 secant plus 1 secant will make? No, I'm adding. X plus X makes 2X. So this is 2 secants. Guys, I have 1 apple and another apple. I have 2 apples. Okay. Take a second and see if you have a thought about the next one. Think about all the different ways that we have started problems. You have lots of options with this problem. Lots of options. Mackenzie?
Can you subtract the sign, since there's a positive sign tracks and then a negative sign tracks, can that go away? Since you're subtracting it away?
No, because we talked about this a little bit yesterday. You have to be careful. This is just like in regular algebra. If you had x squared, y squared, something squared times something squared, minus that thing squared, you would not combine those because they aren't like terms, okay? So it's just like regular polynomials. You can add things together, subtract them if they're like. Like here, I had a secant plus a secant. I can add those because they're the same. There's nothing I can do with that in terms of combining these terms. They don't combine. Okay, so what's another thought?
We switch the cosecant into 1 over sine and then cancel.
Oh. So why it says one option, I think this is the fastest option, not the only option, but the fastest. He says, look, I got sine squared over 1 times 1 over sine squared. So what's going to happen there? To these two terms right here, what's going to happen? They're going to cancel and make 1. Now I still have a minus sine squared from the other part of the problem, right? Okay, now, I think I just had that on the board. I think I had it right over here. What is 1 minus sine squared? What'd you say? Cosine squared, absolutely. Now, again, you guys, you're allowed to write anything you want on your reference sheet. So over there where it says sine squared plus cosine squared equals 1, remember that identity can be written in different ways, different orders. I can subtract the sine squared, move the sine squared over, and then it looks like that. These are the same equation. You have to recognize that. Now remember, you get a new reference sheet on test day, so you're not going to be able to use the notes that you're taking, but as you're getting used to it, recognize what's sine squared. What if I got sine squared by itself? What would that equal? 1 minus cosine squared. You can always do those substitutions. So 1 minus sine squared is the same as cosine squared. Now, did anybody think about this problem factoring out a sine squared? Because that would be another option. Didn't we do that yesterday? Factor. And you would end up with the same answer. I think it would be maybe one extra step. Okay. All right. How about 16? What are you thinking when you look at problem 16?
This should, or,
Foil? Yes, and thank you for saying that. This is a foil. This is sine plus cosine times sine plus cosine. And remember, even though I'm just saying sine and cosine, if I don't put an X with that sign on my paper, you're gonna lose points. Don't write SIN without putting an X or a theta or whatever letter you want to use. Now we're gonna FOIL. So what's first times first? Sine squared. We're multiplying, sine squared. What's outsides? Sine times cosine. What's insides? Same thing. And last, cosine times cosine is cosine squared. Now, why am I literally jumping for joy? Look at the ends of this problem.
1.
Sine squared plus cosine squared always makes 1. Now, what about these two guys in the middle? Are they like terms?
Yes.
Are they the same thing? So if I have one sine cosine and another sine cosine, when I add them together, I will have
2.
2 sine cosine. And we are finished. All right, last one of those on this paper. Okay, what do you want to do with this guy?
Foil? I
Foil?
can't even see the foil.
What's on your paper? Foil?
Not bad.
So here we go. What do we get when we foil? First things first. Cotangent squared. Outsides. Cotangent times cosecant. Insides. Minus cosecant cotangent. And last. Minus cosecant squared. Notice anything about that? The middle two are the same, aren't they? Except one's positive and one's negative. So this time, instead of adding them together, well, I'll add them together, but they'll cancel out. So I'm left with cotangent squared minus cosecant squared. Now, Tilly, what were you saying? I think you were saying something important.
In the box, it's the second equation, 1 plus cotangent.
So
cosecant.
in the box, one of your Pythagorean identities says 1 plus cotangent squared equals cosecant squared. So, this right here is this right here. Would you agree with that? So cotangent squared minus 1 plus cotangent squared. So I am going to substitute for the cosecant squared. I'm going to substitute 1 plus cotangent squared because that's on my sheet. Now these parentheses are necessary because I'm subtracting. So I'm going to be subtracting each piece. Distributing that negative. And what happens? All I'm left with is the negative 1. All right, got some extra practice here. Now, back in the old days, when I was a real teacher, we had to memorize some stuff. So I thought it would be a good idea, even though we're not memorizing. Some of this you do have to have memorized, and it gets us looking carefully at our pink sheet. So, can you fill in the blanks? Using your own fine line and your pink sheet, can you fill in the blanks? Cosine squared plus sine squared equals 1. What is cosecant? Cosecant is 1 over sine. That one's not on your sheet. You better know that. We used it a lot, right? Today and yesterday, we've used that a lot. All right, tangent. A couple of different definitions. What's one definition for tangent? Sine over cosine. What's another definition for tangent from before, from your orange sheet? Opposite over adjacent. And it's also, there's a third one, y over x. Those are all definitions of tangent.
Or 1 over.
Now be careful. 1 plus what is secant squared? 1 plus tangent squared is secant squared. Claudia, do you need to go see the nurse? I know. Okay. All right, got another one down here at the bottom. 1 plus what is cosecant squared? 1 plus cotangent squared? Uh-oh, now we got cotangent. Lots of definitions of cotangent. So, okay, what are some definitions of cotangent? 1 over tangent. We're going to have 4 definitions for cotangent. So, one of them is 1 over tangent. Adjacent over opposite. What else? 2 more. Cosine over sine. And that probably, Daryl, is the one we're going to be using the most in these problems. And then there's one more. X over y. So there are actually 4 definitions for cotangent. Secant is 1 over cosine. And sine squared plus cosine squared equals 1. Alright, they used to have to memorize all this. You guys have such a list. Okay, number 1. We have used this particular thing twice today. We only done a few problems, but we've done it twice. What is sine squared equal? 1 minus cosine squared. Remember, you can rearrange those identities that you do a box around, can be rearranged. And you have to be comfortable with rearranging them. Sine squared is 1 minus cosine squared. Now, look on your sheet. We aren't going to use this one, but just to get you comfortable with looking at the sheet, what is the tangent of 90 minus x? Can you find it on your pink sheet? The tangent of 90 minus x. I didn't put it on there. I cut it off. Okay, never mind. Cosecant negative x. Did I put that on there? No, I took those off too. So let's skip down to number 4. You don't need to worry about any of these except the ones we're doing. Okay, so number 4, 1 plus tangent squared is secant squared. What goes in the boxes in number 5? Sine x over cosine x. And skip down to number 7. Cosecant is 1 over sine. And remember, you have to have the x. So sine x. And then 9, 1 plus what is cosecant squared? Cotangent squared. And number 10, this one's kind of weird, but you should be able to figure it out. Cosine is 1 over what? Secant. Very good. Because isn't secant 1 over cosine? So cosine is 1 over secant. They are reciprocals of each other. Okay, extra practice 5.1, the next page in your packet. Get out a sheet of paper. You're going to need a sheet of paper. We're not doing these on this page. And there are basically, on this page, there are 2 kinds of problems, okay? So we're going to go through and do all of one kind, and then we'll go through and do all of the other kind, okay? So we're going to start with problem 2. Cotangent times sine. Does anybody have a thought about what we might do with this? Now, there's no squares, so please don't be looking at what you boxed in, okay? You're not using any of those. What do you think?
1 over 10.
Okay, I can think 1 over tangent, but I'm going to say this again, and I know I said it yesterday. Listen to me. When we are changing things into other things, like tangents and cotangents, almost always we're going to use the sine-cosine definition. So what is cotangent in terms of sines and cosines? Cosine over sine. Now, if I do what Claudia said and change cotangent into 1 over tangent, that is not wrong. But then you see where you're stuck at that point? Here, I'm not stuck. What's going to happen? They're going to cancel, and the answer to the problem is just cosine. Some of these problems can be hard. On a scale of 1 to 10, where 1 is easy, 10 is hard, this is a 1. Okay? We need to be able to do this. All right, let's get down to number 4. I'm doing problems that are all basically approached the same way. So what do you think about this one? What are you going to do with cosecant?
1 over sine.
1 over sine. Now, cosine, we're not going to change. What about tangent? Sine over cosine. Now, it's an all multiplication, so everything cancels with everything. So what happens?
Just 1.
Looks like we just boil down to 1. Number 6. like this.
Sine over cosine.
Tangent is sine over cosine. Cosine, we're not changing, so cosine will just be cosine.
Sine.
Our answer is just sine. Okay, number 8. I'm skipping around doing all the problems that are approached the same way. See how all these problems kind of look alike, the ones I'm doing? So I'm doing all these kind first. Okay, what do you think about this one? One over cosine times, it's all multiplied, so times cosine over sine times sine squared over 1. We're not changing in these big long multiplication problems, we're not changing sines and cosines, we're changing everything else into sines and cosines, so hopefully we can cancel. Does anything cancel? Yeah.
And then would it be just one of those?
So that'll cancel. And one of these will cancel. What's left? Sine X. Oh boy, number 9. Looks big. Okay, what are we gonna do? We're gonna change this into sine over cosine. And then cotangent, cosine over sine. And then sine over 1. If you're not changing it, just put it over 1. And then secant 1 over cosine. Okay, let's cancel away. What am I left with? Sine over cosine, which is tangent. So all that big ugly mess just turned out to be tangent. All right, let's look at number 12. Now be careful on this one. What's different about number 12? That's addition. Now I can still change my sign and, or my tangent and my cotangent. But what can I not do? Cancel. Okay? So I am adding these two things together. How do I do that? I need a common denominator. And what will my common denominator be? It'll have to be sine and cosine both. So there's my common denominator, sine times cosine, multiply them together. So both fractions have to have that denominator. So this fraction needs a sign. Would you agree with that? On the top and the bottom. This fraction needs a cosine on the top and the bottom. Do both fractions now have the same common denominator? Okay, so I can add them. So what have I got? I've got sine squared plus, woo, yippee! What do I have on my numerator? 1. And there is your.
Are we able to get rid of the bottom because they're the same?
No, not when you add.
Okay.
No, remember, when you add 1/4 plus 1/4 is 2/4. You gotta keep the bottom. No, bottom stays. If we have an equation, so we had x over 4 plus 5 over 4 equals 7 over 4, then I can say x plus 5 is 7. But that isn't what I have here. So no, when we are adding our fractions, we're gonna keep our denominator. All right, 13. What do we got? Sine squared over cosine squared. Remember, the definition is sine over cosine. If they're squared, then they're just both squared. And what's cosecant squared? 1 over sine squared. Okay. So multiply, I can cancel. And I'm left with 1 over cosine squared, which is what? Secant squared. Beautiful, beautiful, beautiful. All right, try 14 on your own. You should be able to get a good start on 14. Remember, we're not changing sines and cosines. Did you just end up with sine cosine? Sine times cosine? Everybody okay with that? I don't know, this has happened a couple of times. What happens whenever I multiply a tangent times a cotangent? What happens? Aren't they gonna cancel out? That kind of makes sense to you, I hope. Tangent and cotangent are reciprocals. So it's like multiplying 4 and 1/4, aren't they gonna cancel every time? So if you can remember that and it doesn't confuse you, when you look at this next problem, which is number 18, what do you see right here? A tangent times a cotangent? And what do you know is gonna happen when you multiply those? They're gonna cancel. So if you wanna go ahead at this point without writing it out and say 1, that's fine. If that confuses you, then write it out. But you don't have to, because they're always gonna cancel. What about cosine and secant? Aren't they gonna cancel? So what is the answer to problem 18? Sine. Now again, it will always be that reciprocals cancel when you multiply them. So if you have a sine times a cosecant, they're gonna cancel every time. If you wanna write it out like this, you absolutely can, but you don't have to. canceling the 19. So I need to write it out. So I have sine squared over 1. Okay, what's secant? Secant's 1 over cosine. And what is cotangent? Cosine over sine. These are going to cancel. One of these will cancel. What's the answer to the question? Cosine. Kids, I hope you're getting the hang of this. All right, number 21. What's tangent? Oh my gosh, what's tangent? Sine over cosine. What's secant? 1 over cosine. And what's cosecant? 1 over sine. Now be careful. Are the cosines going to cancel? No, they're both in the bottom, so they're going to get multiplied. So these are going to cancel. What's going to be on the top of this fraction? 1. And on the bottom is cosine squared. And what's 1 over cosine squared? Secant squared. 1 over cosine is secant. All right, and then 23 is the last one of this kind, number 23. Now, I want you to look up here for a minute. Those of you that are getting the hang of this. I have 3 tangent and then I have cotangent squared. So I wrote my cotangent separately, which is fine. Because what do I know happens whenever I multiply a tangent and a cotangent? They're going to cancel. They're going to make 1. So what's left? These are going to cancel. What's left? 3 cotangent. And that's the answer to the question. Now, if you want to change everything into sines and cosines and do this, I want you to do that, if that's what you want to do. But know that every time you multiply a tan and a cotan, a cosine and a secant, a sine and a cosecant, they're going to cancel. Whether you write them out or not, they're going to cancel. Okay, so at some point, not our next class, but the one after that, we're going to have a quiz over this, okay? And you are going to have to be able to do problems like we just did.
Just those?
No. Now we're going to work on the rest of the problems. Now the rest of the problems are going to use your identities. Mainly the ones you drew a circle around. Now, half the battle is looking at this problem and saying, whoa, that doesn't look like all the ones we just did. Would you agree with me? All the other ones were something times something times something times something. This is different. Okay? So I want you to look in your box on your pink sheet. What does cosine squared equal? Please don't say 1 over secant squared. It equals that, but that's not where we're going. Look in your box. What does it equal? 1 minus sine squared. So I'm going to change my top into 1 minus sine squared. Mrs. Ford, why would you do that? What is my objective? To simplify. And if I'm going to simplify, I need to be able to cancel. And the only way I can cancel is if things match. So now, I still can't cancel, but at least I have signs. Alright, look at your numerator. What is special about 1 minus sine squared? We've done it. First problem we did today and one that we did yesterday. Difference of squares. How does that factor? 1 minus sine squared. How does that factor? Come on, guys. How does the difference of squares factor?
Sine.
1 minus sine, 1 plus sine. Okay, we went through this yesterday. I'm going through it again and then I'm done. Okay, this first year algebra. You learned it in first year algebra. A squared minus b squared is a plus b, a minus b. The only rule is that number has to be a square. Is 1 a square? Yeah, 1 squared. And that number has to be a square. There it is. So anytime you have a square minus a square, you are going to be able to factor it like this. Okay? So it's time to wake up, it's time to engage, it's time to think. Get it in there. Now, take a look at the problem. Once I have factored, now it's a multiplication problem. This times this. And once it's a multiplication, now I can consider canceling. 1 plus sine, sine plus 1. Are those the same thing? They are. So the answer to the problem is 1 minus sine. Number 3. Look at your sheet. In the box that you made, is there anything in there with secant squares? What does it say? 1 plus tan squared is secant squared? So you can do this a couple of different ways. What happens if you move this 1 to the other side? What does that equation say if you move the 1 over here? Tangent squared equals secant squared minus 1? Wait a second. Secant squared minus 1 is tangent squared. So now I have tangent squared over tangent. What does that reduce to? Just tangent. 5 looks almost the same. It's gonna be a little bit different. 5 is very much like this first problem we did. My job is to simplify that. Jack? Well, I can't just put a 1 in. But what I can do, Jack, is look over here. What does tangent squared equal? Squared minus 1. So I'm going to change my numerator into secant squared minus 1. Please, no canceling. What do I have to have before I cancel? I gotta have a multiply. I have no multiply here.
Do what you did on
Do what I did on the first one, which is factor this as the difference of squares. So how will that factor, Josh?
It would be 1.
No.
No. Secant.
Secant.
Secant plus 1. Secant minus 1.
Yep. And then since I now made it secant plus 1 times secant minus 1, now I can cancel. And the answer to the problem is just secant plus 1. Okay, somebody, please tell me what to do with number 7. Okay, so can I factor the numerator?
Yes.
Okay, now, where do I go after that though? If I factor the numerator, it factors 1 plus cosine, 1 minus cosine, that would not be wrong. But does that take me anywhere? No, because what's in the denominator? The sign, right? And I can't cancel sines and cosines. So maybe instead of factoring, which I could do, that would not be wrong, I just get stuck at that point. What else do you notice about that numerator? It equals sine squared. The numerator is sine squared. Now I'm gonna go through this one more time, but this is another one where it's time for you to think. It's time for you to quit just copying down and start thinking. Sine squared plus cosine squared is 1. That equation can be rearranged. So if I move the cosine to the other side, if I bring him over here, then I'll have sine squared equals 1 minus cosine squared. So every time I see a sine squared, I can change it into 1 minus cosine squared and vice versa. Now, why was that a good idea? Because now I can cancel.
Would it be the same without the cosine, like, up there?
You gotta use the boxes. The boxes have the relationships. So yes, you can do the same thing with any of those identities, but you can't just substitute a tangent. It has its own formula. All right, what was that? That was 7. Oh, number 10. Come on. What are you gonna do with number 10? It's exactly the same problem, except what's 1 minus sine squared? Cosine squared? So the answer to this one is just cosine. Okay, now Jack, number 11 involves tangent. All right, so this is number 11. Does the denominator factor?
Yes.
Yes. However, and that would not be wrong, but after you factor it, secant plus 1, secant minus 1, will that do you any good? No. You can't cancel. So we really need to change, well, I can't really change the tangent into a secant, but what's this? Secant squared minus 1, what's that? Go back to your identity. 1 plus tangent squared is secant squared. This is written on your paper, right there in front of you. What happens if you move this 1 to the other side? Then it says tangent squared equals secant squared minus 1. So when I see a secant squared minus 1, I can replace it with tangent squared. And now I can cancel. Be careful, it will be 1 over tangent. Oh, this is what you've been dying to do. What's 1 over tangent? 1 over tangent. So we will stop there.